my second favorite proof strategy is forward planning. Sometimes backward planning simply doesn't work. And in those cases, forward planning often offers a way out. The basic idea is this. Look at the sentences that you have already established in your proof. This could be the premises in your proof or sentences that you have inferred from your premises. And choose one of these sentences. Forward planning then suggests to use the elimination rule for the main connective of that sentence to deduce further information from what you already know. So for example, suppose that one of your premises is a conjunction. Forward planning then suggests to use conjunction elimination to infer either or both conjuncts. So what does that look like practically? Suppose that at some point in your proof you have established the conjunction A and B. Forward planning then suggests to infer A and B and justify these inferences by citing conjunction elimination. Now, suppose that what you have in your proof is not a conjunction, but a disjunction, A or B. Forward planning then suggests to try to derive further consequences by applying conjunction elimination. And conjunction elimination always requires the use of two subproofs, one for each disjunct. And so I'll just set up my proof by drawing two additional vertical lines, one for each of my subproofs, and putting A on top and B on top of the one and B on top of the other. And then I consider what I can derive from A and B to see whether I can come to a common conclusion C in both cases, since that then would allow me to infer C by citing disjunction elimination. So that's the basic proof setup if my strategy is forward planning and what I have in my proof already is a disjunction. Now, suppose that what you have in your proof already is a conditional if A then B and the antecedent of that conditional A. Forward planning then suggests to use conditional elimination to infer the consequent B and citing the inference rule conjunction elimination. Now it's important here that you need both lines, if A then B and A in your proof, since otherwise you cannot apply conditional elimination. Conditional elimination always requires two lines in your proof. Suppose that what you have in your proof already is a negated sentence, A. And you also have the unnegated sentence or the sentence that's embedded in the scope of the negation sign A. Forward planning then suggests to use negation elimination to infer bottom. Now, finally, suppose that what you have in your proof is bottom. Forward planning then suggests to use the rule explosion or bottom elimination to infer whatever you may need in your proof. It may be the sentence A, it may be something different. Whatever you need in your proof, you should infer and justify that inference and by citing bottom elimination. This proof illustrates the use of forward planning as a proof strategy. I'm here trying to prove the disjunction A or D from two premises. The first premise is a disjunction, A or B and C, and the second premise is a disjunction as well. It's not the case that B, or it's not the case that C or D. Now, backward planning in this case doesn't help me. Backward planning would suggest that in order to prove A or D, I should prove either the first disjunct or the second disjunct and then infer my conclusion using disjunction introduction. But looking at my premises, I'm pretty quickly certain that I will not be able to prove A and I will not be able to prove D. So disjunction introduction is not going to help me to get to my conclusion. So let's try some forward planning. Forward planning says that I should look at my premises and then use the corresponding elimination rule to get further information out of these premises. Now both my premises are disjunctions, and that means that I should use disjunction elimination to try to prove my conclusion. And that's what I'm gonna do here. And I'm just gonna go ahead and work with the first disjunction here. So I'm going to set up two subproofs, one for each disjunct. And at the top of the first subproof, I'll put A, my first disjunct, and then at the top of the second subproof, I'll put B and C, which is my second disjunct. And in either case, my goal is to prove A or D, since if I'm able to prove A or D in both cases, then I can infer my overall conclusion by citing disjunction elimination applied to lines 1 and the two subproofs. So the first subproof is pretty quick and easy. I start with the assumption that A, and I infer A or D, citing a disjunction introduction applied to line 3. So that's done. The second subproof is more complicated. I start by assuming the conjunction B and C, and I want to get to the conclusion that A or D. Now, how can I do that? Let's do some forward planning again. My second premise here is also a disjunction, and forward planning suggests that I should apply disjunction elimination to get to my desired conclusion, A or D. So I'll just set up two subproofs, one for each disjunct. I'll start with D, and the second subproof I'll start by assuming not B or not C. And in either case, my goal is to get to the conclusion A or D, since I can then infer A or D by citing disjunction elimination again, applied to lines 2 and the two subproofs. Now, the first subproof that starts in line 6 with the assumption D is pretty quick and easy again. So if I assume D, I can infer A or D by citing disjunction introduction applied to line 6. So there I'm done. The second subproof is a little more difficult. I start with assuming the disjunction not B or not C, and I want to derive the disjunction A or D. How can I do that? Well, I see that I again have a disjunction. So forward planning again suggests I should use disjunction elimination. And that's what I'm gonna do here. I'm gonna set up two subproofs. The first one starts with the assumption that not B, which is my first disjunct. And the second starts with the assumption that not C, which is my second disjunct. And in either case, I want to derive the conclusion that A or D, since I can then justify it down here by citing disjunction elimination applied to line 8 and the two subproofs. Okay, so how can we complete these two subproofs? The first subproof starts with the assumption that not B, And I see that I have the conjunction B and C in line 5. So I'm gonna go ahead and apply conjunction elimination to line 5 to derive B. And then I can infer bottom since I have a contradiction in lines 9 and 10. And I'm gonna justify this inference by citing bottom introduction applied to lines 9 and 10. And then I can infer A or D and cite explosion applied to line 11. So that's my first subproof. And the other one is pretty similar. I start by assuming not C. And then I'm going to apply conjunction elimination to line 5 again to derive C. And then I can infer bottom by citing bottom introduction applied to lines 13 and 14. And then I can infer A or D by citing explosion applied to line 15. And now I just need to fill in the gaps, in particular supply line numbers for my inferences in lines 17, 18, and 19. So line 17 is justified by disjunction elimination applied to line 8 and the two subproofs from 9 to 12 and 13 to 16. So that's what I'll put here, 9 to 12 and 13 to 16. Okay, good. Now line 18 is justified by disjunction elimination applied to lines 2, 6 to 7, and 8 to 17. So that's what I am going to write here, 6 to 7 and 8 to 17. And then my final conclusion in line 19 is justified by disjunction elimination applied to line 1 and line 3 to 4 and the second subproof from 5 to 18. Okay, and that completes my proof.